Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, nice to meet you. My name is Rizka Zuliana. I am a student of Tanjung Pura University. In this time, I want to talk about how does lightning form. First of all, let's begin by definition of lightning before looking the process. Do you know lightning? Lightning is essentially a giant spark that occurs either within a cloud or between the cloud and the ground. For a phenomenon that occurs so frequently, how lightning originates is not widely understood. The leading theory is that it is related to the build-up of an electrical charge as hail and smaller ice particles collide with each other within a cumulonimbus storm cloud. That's all we have to say about definition of lightning. Now we see how the process happens in the cloud. Small water droplets are propelled towards the top of the cloud by strong internal winds, or updraft, where they turn to ice. Some of the pieces of ice grow into hail, but others remain as small particles. Some of the hail that forms becomes too heavy to be supported by the updraft, and so fall back through the cloud, bumping into smaller ice particles as they do so. During these collisions, electrons are transferred to the hail, giving the hail a negative charge, while the ice particles that have lost electrons gain a positive charge. The updraft carry the smaller ice particles upward, giving the top of the cloud a positive charge. The heavier hail falls towards the lower part of the cloud, giving it a negative charge, effectively forming the opposite poles of a battery and inducing an electric field. That's all I have to say about the small water droplets that turn into hail and collide one each other, so that there are electrons which are negative charge and positive charge. Now we'll move on to next step. How is the negative charge built at the base of the cloud be attracted to the positive charge on the ground? As negative charge built at the base of the cloud, the electrons near the ground are repelled. This leaves the ground and the objects on it with a positive charge, as well as being attracted to the positive charge on the ground. The surplus of the electrons in the cloud base are attracted to the positive charge in the top of the cloud and in other clouds. As air is not a good conductor, the electrical current doesn't easily flow between the opposite charge. Only when the charge difference is large enough can a connection be made allowing current to flow balance the charge separation. But the current doesn't flow instantly. There can be many negatively charged stable leaders that grow or step downwards from the base of the cloud. That's all I have to say about the surplus of the electrons in the cloud base are attracted to positive charge in the top of the cloud and in other clouds. Let's turn now to the next step about the process of a lightning strikes. This is how the process of lightning happened and other facts. Objects on the surface, particularly pointed ones, respond to the strong electrical field by reaching out positive or upward streamers. The streamer that meets the stepped leader is not necessarily the one from the tallest or closest object. The first leader to meet a positive streamer establishes the path and allows for the sudden massive discharge of the electrical currents traveling at around 270,000 mph. This return stroke is the lightning flash that you see, although often assumed to be the same thing. There is a key distinction between lightning flashes and lightning strikes, which are separate pulses of currents that occur only hundredths of a second apart, giving the flash a flickering appearance. The huge amount of electrical current in a lightning strike produces an enormous amount of heat. The narrow channel of air through which lightning travels is only about 2 until 3 centimeters wide, but it reaches temperatures of up to 30,000 Celsius degree almost instantly. That's 5 times hotter than the surface of the sun. This heat is what we see as the brilliant white blue flash. It is also the cause of the thunder. The rapid heating of the air produces a shock wave, which is the thunder that we hear. We've looked at there is a key distinction between lightning flashes and lightning strikes, which are separate pulses of current that occurs only hundredths of a second apart. Finally, I want to say that so long the process of the form of lightning, but it happened all very quickly. Lightning and thunder are two different things. Okay, everyone, that's all about my topic. Thank you very much for your kind attention. See you!